In this video, we'll be looking at the shape of a distribution and how that shape can be used to make decisions related to how to work with our data. Okay, so now you might be wondering, what does she mean by the shape of a distribution? You may recall learning how to create a histogram. Look at the shape created by the top of the bars in our histogram. This is the shape of our distribution. We also recently learned how to make a stem and leaf display. The shape created by the last number in each leaf also tells us the shape of a distribution. Before we start to look at what the shape of a distribution tells us, there are a few important terms that we need to understand. A mode is the value in our dataset with the highest frequency. Looking at a graph, if we see one hump, the data is said to be unimodal. With two humps, the data is bimodal. And with more humps, the data is multimodal. Don't worry, we'll see more examples in a minute to make sure you understand this. The ends of our data, where the lowest and highest values in our dataset fall, are called our tails. On the right side is our right tail, and on the left side is our left tail. If a line can go through the center of our display, making the left side a mirror image of the right side, our data is said to be symmetric. Okay, now we know enough to start using these terms. To summarize quantitative data, we need a measure of the center. By this, I'm referring to the mean or median. We also need a measure that tells us how the data is spread. This could be either range and interquartile range or standard deviation. We'll look at how to calculate these numbers in future lessons, but for now, let's make sure we know how to select the appropriate measurement to calculate when presented with a set of data. If we display our data in a histogram or a stem and leaf and find that our data is unimodal, the tails mirror each other, and the data is symmetric, it is ideal to use the mean as our center and the standard deviation for spread. If, however, any of these conditions fail, for example, the data is bimodal or multimodal, the tails are uneven, or the data is skewed and the display is not symmetric, we use median as the center and the range and interquartile range to describe the spread. In the example we previously looked at, the graph was unimodal, the tails mirrored each other, and the graph was symmetric. So we would summarize this data using mean and standard deviation. Let's look at another example. Here we have a stem and leaf. To visualize the spread, think of it as a sideways histogram. There is one mode, so the data is unimodal. However, the left tail stretches out much further than the right tail. With a longer left tail, the data is said to be left skewed. This leads to the display not being symmetric, which indicates that we need to use the median as the center and range and interquartile range for the spread. Let's look at one more example. Notice here that our histogram has more than one hump. Even though each hump doesn't go up to the same frequency, our data is still considered to be multimodal. It is also clear that the display is not symmetric, so we should use the median, range, and interquartile range to summarize the data here as well. Here's a summary of what we've learned in this video. Center and spread are important to address when summarizing quantitative data. Histograms and stem and leaf displays tell us the shape of our data. Mean and standard deviation are used to summarize symmetric unimodal data. Median, range, and interquartile range are used to summarize skewed or multimodal data.